Hey class, Absolute 5 here again. So today we're going to talk about calculating the limit. When we're talking about calculating the limit, we're just talking about the properties of what can you do with the limit. So what do I mean by this? Suppose that C is a constant and the limit as x approaches a of f of x and the limit as x approaches a of g of x exist, then we have these properties. 1. The limit as x approaches a of f of x plus g of x, close bracket, you're allowed to distribute the limit as if it were part of the distributive law. So you have the limit as x approaches a of f of x plus the limit as x approaches a of g of x. You're allowed to distribute that. This is true for, to make this easier, this is true for both addition and subtraction. This is true for both. So I'll make that a little change. This is true for both addition and subtraction. We also have the limit as x approaches a of some constant function, some constant c of f of x, close bracket. This is just saying that you're allowed to factor out or take out a c so you're able to put the limit for the function, because let's be honest, a constant is just a constant. It's not going to affect the function heavily as some other functions would. Now, I think I have room for the third property, which is, we have more properties still. The limit as x approaches a, where we take two functions and as we're multiplying them, you're allowed to take the limit as x approaches a of f of x times the limit as x approaches a of g of x as well. So what this is saying is during multiplication, you're able to still squeeze in a limit between these two functions. By the way, we still have one more property to go through. The last one I'll put on top here. The limit as x approaches a of a ratio of a function f of x and g of x, you're allowed to put the limit in the numerator of f of x and the limit as x approaches a of g of x as well. However, this is only true if the limit as x approaches a of g of x does not equal 0. So it's really important to know these are 5 properties, even though I put 4, because there's another property for subtraction, but it's the same thing, just separately for subtraction. So if you were to break it down, these are what you can essentially do with the functions. Of course, you're able to raise the function by another power. I'll get to that another time. But for the basic, these are like the basic operations which you can do to any of these functions. Like I said, there's more, but I didn't get a chance to go over that, but I will in another video. So let's give a quick example for each one real quick. Okay, so the first one, we'll just call it A. The limit as x approaches 1, parentheses, x squared plus 2x plus 1, right? You're able to simply, again, take the limit as x approaches 1, you get x squared plus the limit, well here it's like a 2 in 1, plus 2 times the limit as x approaches 1 of x plus the limit as x approaches 1 for 1. This is a constant, nothing happens to this. So as x approaches 1 for here, this becomes x's squared. It becomes 1 squared plus 2 times 1 plus 1. We get 1 plus 2 plus 1, which is just 4. Okay? For b, the limit as x approaches 2 for 10x minus 6x squared, we plug this in, so we get 10, the limit as x approaches 2x minus 6, the limit as x approaches 2x squared, we get 10 times 2 minus 6 times 2 squared. Let's move it over here. I get 20 minus 6 times 4, 20 minus 24, and I just get negative 4 as the limit. For the third one real quick, C, call it C, the limit as x approaches negative 2 of 9x to the third, again, as you've been noticing, I've been pulling out the numbers out in front. You're able to do that here. We can make this 9 as the limit as x approaches negative 2x to the third. We'll put this up here. Maybe you can see that. So this becomes 9 to the negative 2 to the third. This becomes 9 times negative 8, negative 72. So limits are simply, you're kind of just plugging in the value, but the thing is the limit has to exist for it to actually work. So now let's take D. Let's say we use some trigonometric functions. Let's say I gave you the limit as x approaches 0 of sine of x times cosine of x, right? So again, from that property, it becomes the limit as x approaches 0 of sine of x times the limit as x approaches 0 of our cosine of x. So we have the sine of 0 as times cosine of 0, which is just going to be 0 times 1, which is just 0. And lastly, for the fifth one, for the last property, for E, the last property is the limit as x approaches 1, x minus 1 square over x minus, x minus 2x plus 1 all over c squared as x approaches 1, right. So the point that I wanted to show you this is because this function here, if you simply plug in the function, the limit as x approaches 1 to every single thing, including the numerator and the denominator, this would become 0, which is a problem. We don't want that at all. So to remedy this, we have to factor this one on top. So how do I factor x squared minus 2x plus 1? Well, if you know what this is just simply x minus 1, x minus 1. So then, right, x times x gives me x squared. X times negative 1 is negative 1x. Negative 1x times another negative 1x. I have two negative x's. So this becomes like this. X squared minus x plus 1. It looks like this, so you combine these two, so we still get negative 2x. So this becomes the limit as x approaches 1, x minus 1 times x minus 1 all over x minus 1. I'm able to cancel these two. So we take the limit as x approaches 1, x minus 1. So this just becomes 1 minus 1, which is 0. So the function now exists because if we plugged it in, we would have gotten a 0 in the denominator, which means this ratio, this function here, would not be defined. It would be considered undefined. Since we factored it, it now exists as 0. So I hope that made sense today, understanding some properties of functions. I know there's others. I'll get to that another time. So this has been Absolute 5. I'm Roger Palomino. And be sure to like, share, and subscribe to my channel. And if you like to hear more about my videos, about my content, be sure to hit the bell button right next to the subscribe button. And I will see you guys next time for another video on the calculus. And always, guys, remember, math is infinite because there are infinitely many possibilities. And have yourself an absolutely lovely day.